Okay, so just use me as an answer key. You know the ones that you just had no idea. So if I get to those ones, watch me. But if I'm doing the ones that you're like, you think you pretty much knew how to do it, don't just sit there listening to me. You work ahead. All right, so problem number 1. We have function f is the first function. I'm going to talk a lot to you because you were absent yesterday. Function f is the first function. So the first function is 4x. Now I'm not going to write down 4x. I'm going to write 4 parentheses. I put parentheses in place of x. Okay? Now inside the parentheses I see I've got g. So I look up and I see what's g? X squared minus 4. So that's what goes inside the parentheses. So I go x squared minus 4. Then you see I'm going to need the distributive property. So I'm just going to distribute like this. So that's going to give me 4x squared minus 16. So that would be it for that one. That's all. Okay? Number 2. Function g is the first function. Function g says x squared minus 4. I'm not going to write x squared. I'm going to write parentheses squared. Always just put parentheses instead of x. So parentheses squared minus 4. I encourage everybody to write that first, write down the function with parentheses first, and then go back and plug in. If you try to do it all in one step, you might be okay, but I see some kids make mistakes. Then I put in the f of x. F of x is 4x. So that tells me, okay, put that in now. So I put in 4x. So I just need to square the 4x. So that's going to make 16x squared minus 4. So that's it for number 2. Yes, darling. You have to do 2 sets of parentheses when you have a binomial or something. So something more than just one term. Now, say if I did 2 sets of parentheses. That would make the 2 sets of parentheses would be 4x and 4x again, right? Now, what would you get when you multiplied these 2 parentheses together? Which is exactly the same thing. So, if you got in the habit of writing it twice, you're always going to get the right answer. But the time when you would absolutely have to write it separately like this would be something like this. And say if instead of being 4x, say if it had been x plus 4 squared. Minus 4, whatever. This time, I can't just square the x and square the 4. When it's a sum or difference in there, that's when I have to do x plus 4 times x plus 4 and FOIL it. But if it's just a monomial, just one term with no plus or minus, you can just square the 2 things that are there. Okay. See, will it let me get to my... Any questions on 1 or 2 so far? All right, so number 3. Yeah. On number 3, we have h. Function h is the first function. So I'm going to start with that, 5x plus 10. But I'm not going to write 5x plus 10. Oh, no. I'm going to write 5 parentheses plus 10. That's my 5x plus 10 with parentheses. Now, what am I going to put inside the parentheses? X squared minus 4, because that's my g. So I'm going to put x squared minus 4 in there. Okay? Now, what am I going to do next? A little distributive property, yeah? So that's going to give me 5x squared minus 20 plus 10. Combine these like terms right here, and that's going to leave me with 5x squared minus 10. So that would be the answer for number 3. Any questions so far? Alright, look at number 4. For number 4, the first function is f. Let me look back and see what f was again. Oh, so function f is 4x. I'm not going to put 4x. I'm going to put 4 parentheses, because I always put a parentheses instead of the x. So that's my 4x. Now I'm going to put in function h, because that's what's on the inside. So inside of here I put 5x plus 10. Little distributive property now is going to give me 20x plus 40. So that would be the answer. Any questions about number 4? Okay. Now, everybody should stop whatever you're doing. The answer to which one? You saw it? Everyone should stop what you're doing and pay attention to the next couple problems, because we didn't do any exactly like this yesterday. So this is a little bit new. It's hard to see the problem. Okay. So the thing that's new is there's a number inside of there. Now, there's 2 different ways I could approach this. Maybe you guys can tell me once and for all which way seems the easiest to you. This is how I would approach the problem. When you have an actual number in here, a number inside of a function inside of a function, the strategy would be to work from the inside out. Do the inner function first. In other words, look, we have h at -3, right? I will do the inside function first. So let's see, how do I do h at -3? What do I do with that? Right, you see function h over here, right? So, substituting -3 for x is going to go ahead and give me 5 times -3 plus 10. So, that's going to be -15 plus 10. That's going to be -5. Okay? That's the inner part. I have now figured out what h of -3 is. Now that I have that, I feel like changing colors. Now that I have that, now I can do the outer function, function g. Okay? But I'm going to take this -5 and plug that in, because I'm supposed to do g at h at -3. But h at -3 turned out to be -5. So now I can just go ahead and do g at -5. To me, this is the most straightforward way to do the problem in 2 steps, 2 stages. So now we'll do the g. Function g is this one. So now I will do x squared minus 4. So that's -5 squared minus 4. So that's positive 25 minus 4. So that's 21. And that would be the final answer to the question, 21. Note, I'm remembering back for previous years. I try to remember the mistakes that students make so I can emphasize and help you avoid it. Last year, some kids thought that there were 2 separate answers to this question, and they would write down both answers for me. They would give me -5 and 21 as 2 separate answers. Or some kids would plug in -3 twice. They would plug in -3 to h and get -5, and then they'd plug in -3 to g and get some other answer, and they give me those two answers. That is not the thing to do. You plug the number into the inner equation, get an answer. You take that answer, put it into the second function, and whatever you get is the overall answer to the question. Only 21 is the answer. Okay? So let's do that again with number 6. So what am I going to do first then, you guys? What did I just teach you? Do the -1 into which function? F. Inner function first. So I'm going to start with f at -1. Why won't that stick? So let's see. There's function f over there. So that's going to be 4 times -1. Goodness. So that's going to make -4. It's not like these negatives. That's going to bug me. And then what do I do? Yeah, plug the 4 into function g. So function g again is, alright, I'm going to do g at x now. Ugh, I didn't mean to do it that way. I'm going to do g at -4. So that's going to give me, g is x squared minus 4. So -4 squared minus 4. So that's 16 minus 4, so that's 12. Señor Pérez, por favor, deja de hablar. Muy bien. Any questions on 5 or 6? We good? Okay. Look at number 7. It's okay that we're going to do the same function twice. We're going to start with function h. Oh, I got to look back and see what h was. 5x plus 10. Yes, sir. If you're consistently getting the same answers as me, you're fine. I'm sure you're fine. Just make sure you're getting the same answer as I am every single time. Now you just made me forget what the function was. 5x plus 10, thanks. Okay, function h is 5x plus 10. So when I do h at -2, that's going to be 5 times -2 plus 10. So that's going to make -10 plus 10. So that's going to make 0. Okay? Then I take that 0 and I plug it into the outer function, which happens to be h again. So now I'm going to do h at 0. So that's going to be 5 times 0 plus 10. So that's going to be 0 plus 10, which is just going to be 10. So the final answer, number 7, would be 10. Take a moment and do number 8 on your own, in case. Okay, so number 8. So we start with function h again. So I'm going to do h at 3 first. That's going to be 5 times 3 plus 10. That's 15 plus 10. That's 25. Then I do f at 25. Right? Because I'm taking this guy and I'm putting it in there. What was function f again? 4x. Okay, so this becomes 4 times 25, which is 100. okay? Nod if you are getting these right. Nod at me if you're getting these right. Okay, okay. Any questions? Anybody need some help right now from me? Okay, let's scroll on. Let's scroll on. Okay, new set of functions. Subtraction. Be careful when you're doing subtraction. The main mistake that children make with subtraction is they forget to distribute the negative sign. We're going to have to distribute the negative sign. So here we go. Function D minus function H. Let's see. So function D. So that's 2x squared minus 8 minus function H, which is 4x squared plus x minus 3. When you have subtraction like that, you must distribute the minus sign. So I'm going to have to take this negative sign and apply it to each one of these things on the inside. That's going to make this become negative 4x squared minus x plus 3. Can everybody see how I got the red part here? Is that clear? That negative sign in front changed all the signs of everything inside. Please don't forget to do that. Now the other part just comes down unchanged. So I will bring down my 2x squared minus 8. Now I'm just combining like terms. 2x squared combines with the negative 4x squared. What do I get when I put those together? I get negative 2x squared. And then I've got the x sitting here. It doesn't really have anybody to be with, so it just sits all alone. Just bring it down. But then we've got the negative 8 and the 3. Those are like terms. We can put those together. That's negative 5. Okay? So that's the final answer right there. Any questions about number 9? Now, we're supposed to state domain restrictions this time. Don't ignore that part. If it says state the domain, remember to watch out for any restrictions. Are there any restrictions involved in problem number 9? No, there are not. Remember the two restrictions that we discussed yesterday? Who can tell me one of the restrictions we discussed? Square root was one of them. What can you not have under a square root? Negatives. So that's one restriction. No negatives under the square root. What's the other restriction we talked about yesterday? 0 in the denominator. No 0 in the denominator. So, but on this problem we have no square roots and we have no denominators. So we don't have to worry about that. So the domain is negative infinity to positive infinity. Okay, number 10. B of x over h of x. So let's see. B of x is negative 2x minus 2. H of x is 4x squared plus x minus 3. Now, there are two things I need to point out to you. In fact, this is one of those that everybody should stop, even my super geniuses. You should pay attention, because we haven't done a problem exactly like this before. There's new stuff kind of in here. One mistake that kids make is thinking that they can cross out things here in the numerator and denominator. Some kids would think, oh, I can cross out this x up here with this x down here, or something. When things are connected by addition and subtraction, you cannot cancel them out in the fraction. So I have a plus and a minus, and I have a minus up here. I'm not going to be able to cancel out any of these things. So definitely don't do that. Well, you might think that since I can't cancel out anything, I'm done. And sometimes I would be. But in this particular problem, there's more that I can do. Before I just tell you, does anybody have any guess why there's more I can do on this problem? Anoop? Never mind. What about it? You're thinking of negative exponents. The key is factor. Do you know what I mean when I say the word factor? We can factor. Both the numerator and denominator can be factored. Who has any idea what I'm talking about when I say those words? That's ringing some bells? Okay. In the numerator, and you know, I might need space. I think I'm going to need some extra. Whoa. See if I can do it down here. I think I'll need extra space. Yeah, watch this, guys. It's been a while since we factored, so pay attention. In the numerator, there's a GCF, a greatest common factor. So let's pull that out. What's the GCF in the numerator? Right, well, just the 2 part, since there's no x on this one. The negative 2, yes. So looking at that numerator, I'm going to bring out the negative 2. Now, if I bring out this negative 2, be careful. What's that going to leave on the inside of the parentheses? X what? Not minus. It's going to be x plus 1. Now, the reason why I know it's going to be plus 1 is, imagine I did the distributive property now. If I took that negative 2 and distributed it, it should get me back to where I started from. Negative 2 times x, that's negative 2x. Negative 2 times positive 1 will give me my negative 2 back again. If I had put a negative 1 right here, if I distribute, that would give me a positive 2 back. So that's how I know it can't be positive. That's how I know it can't be negative 1. Now, the denominator, with that trinomial down there, I'm hoping you guys are recognizing factoring is going to work like this. It's most likely going to be a binomial times a binomial when we factor this. It's been a while, and we sort of struggled with it when we learned it fresh. So this is a good review, so pay attention. When I see 4x squared, my first guess is to play around with 2x and 2x. Now that might not work. If it doesn't work, I'll have to come back and erase and try 4x and x. But I always would start with this first. Then I've got this 3. And I think, okay, 3 is 3 times 1. Now, remember this? The inner and the outer have to give us the middle. I feel like changing colors. Okay, inner. What do I have inner right here? I have 6x. Okay, outer. What do I have outer? I have 2x. Am I going to get an x out of that, a plain x? No. I'm not going to get an x out of that. That means 2x and 2x is not working for me. So I'm going to erase that and try again. Whoa. Okay, I'm going to erase that and try again. Okay, so instead of 2x and 2x, I'm going to try 4x and x. Okay? Now, if I have it this way, now what are my inner and outer? So inner is 3x. What do I have outer? 4x. Okay? Can I get a 1x out of that? Sure I can. What would the signs have to be to give me a 1x? Yes, now be careful. I want a positive 1x result. So which one of these needs to be negative? I would need a negative 3 and a positive 4 in order to get positive 1 like my middle. So that's what I'm going to do. Okay, so there's my negative 3 is going to go here. And putting a positive here, my positive 4 that I need. So those would be my signs. I always check one last thing. Does negative 3 times positive 1 make negative 3? It does. So that worked. Okay? Now, watch this. The reason why it was so important that we factor. Let me erase some of this extra stuff. Remember when I said we couldn't cancel out things that were connected by addition and subtraction? Do you see anything that we can cancel out now?
X plus 1.
Right. Now we have x plus 1 here and we have x plus 1 here. These parentheses are connected by multiplication. So I can cancel those out just fine. So let's do that. So I'm going to cancel out the x plus 1 and this x plus 1. So that's going to leave me with negative 2 over 4x minus 3. So that's the answer. Okay. Now, the domain. Again, even my geniuses better pay attention, because this is slightly different than what we've had before, just a little bit. Looking at the final answer here, you can probably see that we're going to have some sort of restriction, because we have a denominator with an x in it, and we have to avoid 0. Now, what do I do to make sure to find the number that I have to avoid? Set that denominator equal to 0 like this. We know that 4x minus 3. I wonder, could I do a control Z on that? Oh, look at that. Nice. We know that 4x minus 3 cannot equal 0. Not allowed to be 0. The denominator can't be 0. So now I can just solve this for x, and that will tell me my restriction. So if I add 3 to both sides, okay, more space. If I add 3 to both sides, that's telling me that 4x cannot be 3. Then I divide by 4 on both sides, and that tells me that x cannot be 3/4. So that's a restriction. But is it the only restriction? The fact that I'm asking the question is sort of a hint to you that there's another restriction. Does anyone have any idea why there's another restriction? Okay. Your silence is the reason why even my geniuses need to be paying attention right now. Okay? The reason why there's another restriction is because when we judge our restrictions, we do not just look at the final answer. We have to look at every stage in the process. So look at the previous step, the one just before we crossed out those x plus 1s. Just before we crossed them out, this x plus 1 in the denominator was going to give us another restriction. Can you see it? What's the additional restriction that comes from the x plus 1 that's in the denominator? Well, what? Negative 1. Negative 1. So when we say our domain, we have to say 2 restrictions. X cannot equal negative 1 because of the x plus 1. Even though it got canceled out, it still counts as a restriction. And the one that it didn't get canceled out. X cannot equal 3/4. We need both of those restrictions for our domain. We're saying X can be all real numbers except -1 and 3/4. That's what we're saying.
Well, why is it -1?
Because of the X plus 1 that got crossed out.
So you switched them.
Right, like, yes. I mean, go ahead and think of it as common sense for a minute.
Yeah.
If X was -1, -1 plus 1 would make 0.
Oh, yeah.
All right, but you could, like you said, you could always just set it equal to 0 and solve. Does everyone understand why there are 2 restrictions on that one? Okay, so that was a little tough, but that could be on the quiz tomorrow. You're certainly responsible for it. Okay, so let's keep going. D over C. I gotta look back and see what these were. Okay. 2x minus 8, 2x squared minus 8 over 3x plus 6. All right, can you guys tell me what function D and C were? Over 3x plus 6. Okay. Is there any factoring that we can do, guys?
Yes.
Yes. In the numerator, there's definitely a common factor, isn't there? I can tell I'm going to need more space already. Okay, let's factor the numerator. The common factor is 2. So 2 parentheses x squared minus what? X squared minus 4. What's the GCF in the denominator? 3. So that's going to leave 3. And then what? X plus 2. Is there any more factoring I can do?
Yes.
What is it?
X squared minus 4.
The x squared minus 4. That's the difference of 2 squares. That needs to be factored further. So that's going to be 2. And then what?
X plus 2 and x minus 2.
X plus 2, x minus 2. It's a good thing I factored because now I have to do what? I have to cancel out. These x plus 2's. These x plus 2's cancel out. They go away. So that's going to leave me with 2 times x minus 2 over 3, which would be 2x minus 4 over 3. So that is the answer. Now, waiting. Where did the 4 come from? I distributed the 2 back. In the end, we don't want any parentheses in the answer. So at the we had to factor it, but at the end we have to distribute again. Does everyone see where the minus 4 came from now? Okay, how many restrictions are there going to be? Are there any? There is one restriction. Why? Even though it got crossed out, that x plus 2 in the denominator at that step still is going to count as a restriction. So x cannot equal what? X cannot equal -2 because of this. Even though it got crossed out, it still counts towards our restriction. Okay. All right, B and D. Can somebody read me what function B is?
-2x. Oh, yeah.
Function B, -2x minus 2. Okay, and read me function D, please. 2x squared plus 8. Minus 8? Oh, that's not going to work. Wait, so part of this got erased. It was negative 2x minus 2? Okay, and 2x squared minus 8. Okay, when it's a plus sign like this, do I need to change the signs on the inside here? No, that's only when it's a minus. So really, I don't need the parentheses on this problem. When it's addition, the parentheses are not doing anything. Now, listen carefully. Here's a mistake that probably 3 or 4 of you would have made. Somebody in here would have multiplied. Somebody would have started doing the foiling, doing the distributive property on this problem. I need you to understand that this is an addition problem. We will not be multiplying. We will not be foiling. We are simply going to erase the parentheses and start combining like terms. That's it. What are the like terms? Right, the only like terms are the negative 2 and the negative 8. So put it in order, please. What goes first in my answer? You need to write the 2x squared first, then what? Then the minus 2x, and then what? And then minus 10. So that's the answer for number 12. Talk to me about domain restrictions. Right, the domain, there are no restrictions, so, wow, it is not letting me put these dots. So, negative infinity to positive infinity. All right, good. Any questions? Okay. How many more of these problems are there? Oh, you know what? Let me skip down to the last problems at the bottom, because I won't get there if I don't. I'm skipping down to number 15, y'all. 15. Who can tell me that main formula that we use over and over again when we're finding the rule for a geometric sequence? AN All right, so the first thing is you have to know the rule. You have to know the model. That one is the one that gets used over and over again. So number 15 becomes obvious. Can you just tell me the answer? Equals 4 times 3. Right, to the n minus 1 power. Okay? That's it. That is the rule. They gave us A1 and R. Those are the two things I needed. Please do not multiply the 4 and 3 and make 12. That doesn't work out. The order of operations prevents that. So that is the answer. But for this problem, we're also supposed to find A8. Do you remember how to do that?
Yeah.
How do I do that?
You plug in 8 for n minus 1. 8 minus 1.
You plug in 8 for n in the formula that we just created. Can somebody do that and tell me your answer? 8,748. Any questions on number 15? Number 16. There are two things that we need to find in order to write the rule. We need A1 and we need R. Well, guess what? We're given R. All we need to do is find A1. So here we go. Let's go back to the original formula. AN. Instead of AN, I get to write A3. A1 is what I'm looking for. I've got R, though. That's negative 2. N minus 1 power? That's 3 minus 1 power. Because that's my n right there, the 3. But I know what A3 is, so I put 16 equals A1 times negative 2 squared, because of 3 minus 2. That means 16 equals A1 times 4. Dividing both sides by 4, that means A1 is 4. So now I've got A1 and I've got R. That means now I can write the answer. AN equals 4 times negative 2 to the n minus 1 power. Okay, that's number 16. Any questions on that? Number 17. There's another formula that we have to use for this one. When are we given A1? Are we given R? We're not given either one. When we're not given either one, that's when we use the weird formula that goes like what? That's when we do the A big equals A small R to the big minus small. Okay? So A big, so that's A5, equals A small, so that's A2, times R, I don't know what that is yet. Big minus small power, that's 5 minus 2 power. This becomes A5 is 3,750 equals negative 30 times R to the third power. Dividing both sides by negative 30. What do I get when I divide, you guys? Negative 125. Cancel out. Equals R to the third power. Taking the cube root of both sides. Cube root. What do I get? Negative 5. There are two things I needed to find. I needed to find A1 and R. I just found R. Time to find A1. I find A1 by going back to the good old formula. AN equals A1 times R to the n minus 1 power. I go back home to this formula. Which one of these two values am I going to choose? I'm just going to choose this one because it's small. That's the only reason why I pick it. That means A2. Come on. I know what R is now. Negative 5. To the n minus 1 power. That's 2 minus 1 now, because that's my n. But A2 is negative 30 equals A1 times negative 5. 2 minus 1 is just 1, and I don't need to put it. Dividing by negative 5 gives me 6. So, I have A1 and I have R. I'm ready to write the answer. So the answer is AN equals 6 times negative 5 to the n minus 1 power. Any questions? All right, last problem. The sum. This symbol means do the sum. There is a formula for the sum. The sum formula is this. The sum of the first n terms is A1 times 1 minus R to the n power over 1 minus R. I'm simply going to use that formula. Please understand, looking at this formula, n is 10. A1, that's supposed to be equals. A1, what's A1? 1 half. The A1 is the thing in the front of the function. What's R?
6.
R is 6. That's how you get the three values. And then you just plug them in the formula. So that's going to be 1/2 times 1 minus 6 to the 10th power over 1 minus 6. And we will put that in our calculator. What was the number in the front? 1/2. So we will do 1/2 times 1 minus 6 to the 10th power over 1 minus 6. And so we get this. This is the sum. Okay? That's the answer to the last one. Any questions? If you were to understand all that, you'll be in good shape for the quiz tomorrow. This video will be posted on Edmodo. So if you need to look back and review the steps, go on Edmodo tonight. It'll be there. The 10 was N, which came from the top.